Hey folks, this is Captain Jones here to talk to you about priority, which is the second and last big concept that we get out of discussing operating systems. Today we're going to talk about sort of refresh our understanding of the purpose and benefits of an operating system, and we're going to extend onto that, knowing what we know now about interrupts and priority. And then we're going to discuss this concept of priority and sort of recap how the LC3 is able to implement that, including the priority level bits in the processor status register, interrupt requests, and the interrupt vector table. Let's get started. Okay, so recall from the first lesson in this unit how we realized that this concept of privilege as implemented by the operating system was of a big use to us because it allowed the hardware or the software to encapsulate access to the I/O devices that are on the processor, which performs a number of useful features. It can sort of abstract the interactions with the hardware, so the programmer doesn't necessarily need to know the details of how to talk to the keyboard or the display device. And we can also perform some level of control where we can restrict access to the hardware in certain scenarios. After discussing interrupts, now we have this concept of priority and the ability for the processor to do multiple things at the same time. So, what we can do is say that the second kind of big thing our operating system gives us is this ability to multitask. We can run user programs at the same time have separate interrupt requests or interrupt service routines that can do processing on events that happen, like incoming keyboard data, at effectively the same time as our user program. So we can, since these input and output devices are sending signals back to our control unit, we can kind of update our architecture diagram slightly with these arrows that are coming back to the control unit. And you can see here, if we don't have an operating system and we're trying to do, we have two programs when we run a run. Well, the second one, it's just it's out of luck. There's not a really convenient way for that to happen. But as soon as we implement the operating system, not only do we get this ability to, control access to the hardware, but we can assign these two programs priority levels. And presumably at some point when an interrupt comes in, this other program can get to run and can do its piece of work almost at the same time that the other program is being run. And so we can see here our it's kind of simplified instruction cycle where the requests made to the operating system to change the hardware were completed by the trap instruction here. That happened as kind of a normal flow of instructions, and interrupts were processed right at the top here, so the very first step of the fetch cycle before we start executing the next instruction. If there is an interrupt that's waiting to be processed, then we can go and process that interrupt. And so that made, I think, these fields now make a little more sense. The global interrupt enable and the priority level that are in the processor status register, these were used to determine if there was an interrupt that we wanted to service. And then along the way, we sort of figured out that there's a couple areas in the system space that are of importance to us. So the trap vector table occupies the first 256 spaces in its memory, and the interrupt vector table occupies the next 256 spaces in memory. And that's where we find the starting addresses for our operating system service routines and our interrupt service routines. And so we put all that together, and now we have a processor with some very advanced features. It's able to support some high-level operating system concepts like privilege and priority that allow us to write programs that do some very useful, very robust things. We can start to write programs that look like they're multitasking and that have protected sort of access to the hardware. So in future lessons, we will sort of similarly recap our understanding of memory mapped inputs and outputs, given everything we know about interrupts, and we'll also talk about how to actually kind of write some interrupt service routines to be able to do useful things. All right, folks, that's all I got for you. I'll see you next time.